So today we'll discuss about the delta connection. In the star connection, we have studied that current is same and voltage is different, right? But in delta connection, it is completely opposite. Here, current is different, but the voltage is same. Let's see how it is possible. Like suppose we are having delta connection like this. This is like a delta connection. In this, we are having three wires. One is R, one is Y, and one is B. Okay, so we'll see first across the line voltage. I told you what is the line voltage, that is the voltage across the line. So this is R and Y, so voltage across R and Y would be what? VRY, and the voltage across Y and B would be, this one is R, this one is Y, this one is B. Okay, no, this will consider the main, like main wire. This is so in this question you can ask the same question, like how do we know that is R or B? This is the plain wire. Okay, I'm saying this one is the R. Okay, not this point. This one is the plain wire. This is Y. Okay, and this one is the plain wire. This is B, not this one. So the voltage across R and Y would be VRY, voltage across Y and B would be VYB, and the voltage across R and B is VRB, or we can say VBR. Just consider VBR. Okay, this is a point R, this is a point Y, and this is a point B. Okay, so I'm writing here for this term the voltage between R and Y. These are all line voltage. These are all line voltages now. Okay, so this is again R, this is Y, because as you can see that there is a plain wire, and I told you if there is a plain wire at each and every point, the potential is always same. If there is any element connected between the plain wire, then only in that case potential difference would be different, voltage would be different. If there is a plain wire, then in every point, at every point the potential is same. So this is our, here suppose potential is 100, this is a plain wire up to here. So at this point, the potential will always be the same. So this is for R, this is also I'm considering R. Okay, so this is R and Y are here. Now I am taking for the phase connection. This was for the line connection. So we can write down that VL is equal to VRY is equal to VYB is equal to VBR. These are all the line voltages because these are the voltages connected across the plain line, plain wire. Now we'll see for the phase connection. This is the point across R and Y. So here the voltage is how much? VRY. Okay, this is suppose ZRY, this is suppose ZYB, and this is suppose ZRB. So the potential across R and B would be VRB, and the potential across Y and B would be VYB. Okay, which of these voltages are line voltages or phase voltages? Tell me. These voltages are line voltages or phase voltages? See, for this, if it is related to the impedance, okay, the voltage across the impedance, that is the phase voltage, and voltage we are measuring for the line, that is the line voltage. So if we are measuring across the plane wire, that is the line voltage. If we are measuring across the phase, means across the impedance, then these are the phase voltage. So in this case, line voltage and phase voltage is equal. So we can consider it that VRY for the line voltage is equal to the VRY for the phase voltage. So VL is equal to VPH. But we can conclude that VL is equal to VPH. Okay. And now if we want to see for the current, again I'm drawing a separate diagram. Again we need to draw what? Line current and a phase current. Line current is across the plane wire and phase current is across the wire across impedance, where impedance is there. So this is R, this is Y, this is B. So here is the current IR, here is the current IY, and here is the current IB. This is R again, this is Y again, and this is B again. Here the current is moving connected between R and Y, so I can consider it as IRY. Here the current is moving across R and B, so I am considering it as IBR because I am moving in RYB sequence. Here the current is connected between B and Y, so we can consider it as IYB. Directions I have taken randomly. You can take it opposite direction according to your convenience. Clear? So in this case, what are these? IL is equal to IR is equal to IY is equal to IB. These are the line current. And what are the phase current? IPH means the phase is equal to IRY is equal to IBR is equal to IYB. Okay, clear this thing? Now there is no derivation in your syllabus, so I am not telling you the derivation, that what is the relation, how the relationship of line current and phase current will come, but I am telling you directly the relationship. So the relationship between the line current and the phase current, that is IL is equal to root 3 IPH. Okay, like we are in star we are having VL is equal to root 3 VPH, but in delta connection we are having line IL is equal to root 3 IPH. Okay, so we'll take again IRY as a reference. I am taking IRY as a reference. So if we'll take IRY as a reference, then IRY would be equal to IRY angle would be 0, right? What is the next sequence? If there is a first sequence is RY, next sequence is according to this RYYB, right? So it would be IYB and then angle would be minus 120 degree. Remember now this sequence, there is R, there is Y, and there is B, right? So if I'll take RY as a reference, the angle between R and Y is how much? Minus 120 degree. Angle between R and B is minus 240 degree, and if I'll see it from the above side, then the angle would be plus 120 degree. Correct? So first sequence is RY, second sequence is YB, then the third one is IBR. IBR is how much? Mode of IBR, and angle is how much? First is 0, then minus 120, then another angle is minus 240 degree. Correct? Or we can write it down like that also, IBR is angle plus 120 degree. Understood? It is the same as we have done for the star connection. You can see the previous slide for the star connection. First angle is 0 degree, then second angle is minus 120 degree, and then third angle is, if I'll take, see, you can see it also from here. Angle between R and Y, R is reference, so 0 degree. Angle between Y and B, like from the R is reference, so we'll take from the R. Okay. So R and Y is minus 120 degree. Then angle between B and R is reference. So angle is how much? If we'll see from the upward side, then it is plus 120 degree. If we'll see from the downward side, then it is minus 240 degree. So we can take any one. Clear? So this is what the line voltage or the this is what the line current or the phase current. IRY, IYB and IBR. These are the phase current. These are the phase current. Okay, clear? Now we need to conclude what? Line current. We got phase current, and there is a relationship that IL is equal to root 3 IPH, angle would be minus 30 degree. Remember in star connection what was the relationship? That VL is equal to root 3 VPH, angle in that case was plus 30 degree. But in this case the angle is how much? Minus 30 degree. So there is a difference. In the star connection angle was 30 degree, and in the delta connection there is a difference of minus 30 degree, not plus 30 degree. Okay. So in the case of star connection, what we did, we add plus 30 degree in every angle. Like one angle was 0 degree, then we'll add 30 degree. For then angle was minus 120 degree, then we'll add plus 30 degree. Next angle was 120 degree, then we add plus 30 degree. But in this case, what we'll do? Subtract or add? If it is positive, then we'll add. If it is negative, then we'll like minus 30, like then in this case what would be the value? IR is equal to how much? Root 3 IPH. Angle was 0 degree, so 0 degree minus 30 degree. Okay, so what would be the value? Root 3 IPH. Angle would be minus 30 degree. For IY, what was the angle? Root 3 IPH. Angle was how much? Angle was how much? Minus 120 degree. For so minus 120 degree minus 30 degree, so you'll get root 3 IPH. Angle would be minus 150 degree, right? For IB, how much? Root 3 IPH. What was the angle? Plus 120 degree. Plus 120 degree minus 30 degrees, how much? You'll get root 3 IPH. Then you can say that plus 120 minus 30 is how much? 90 degree. Okay, clear? So we'll have line current as well as phase current. So you just need to remember the same thing, same pattern. That is, first there is 0 degree, then minus 120 degree, then plus 120 degree. Okay, if there is a delta connection and we need to change in star, then we'll subtract minus 30 degree from each the case. Okay, and if there is a star connection, then in that case we'll need to add all the angle, matlab add plus 30 degree for all the angle. So it would be root 3 IPH, that is 90 degree. Clear this thing? Understood? This is the connection for the delta.